Thank you, Jeff, and thanks everybody for the chance to speak today. So Dan did a really nice job setting this topic up today, and I'm going to sort of pick up part two, and so shift gears a little bit here and focus on Lake Huron and Lake Michigan. Is this monitor supposed to be on or no? Okay. It appears I've broken the machine again. There's a huge team of contributors here. I'm flanked by both Dan before me and Mark, who's going to follow me. They're going to have very large contributor slides, but just let it be known that there's a huge group here that contributed to this work. So I'm going to take a little bit of a different tact. I'm going to talk about acoustic surveys in general, provide a little bit of background on these. We've been conducting ship-based acoustic surveys in Lake Huron and Lake Michigan for 22 years. And I think as we look to the future and how we want to integrate surface vehicles or other autonomous vehicles with our ships, I think it's really helpful to look at what we've learned from our ship-based methods over all these years. Then I'll talk about some of the limitations, sources of error in our ship-based methods, and then in particularly focus on this central topic here of vessel noise. And does it affect our estimates in Lake Huron and Lake Michigan? And then finally, what are our next steps? So before 2000, most preyfish assessments in the Great Lakes were based on bottom trawl surveys. Bottom trawls have continued to prove very insightful in terms of tracking species over time, provided very valuable information. And it really wasn't until the early 2000s, however, that acoustic surveys were adopted by fishery managers and fishery agencies. There was a Council of Lake Committees report in 2003 that was focused on the large vessel program. And in particular, this report called for a new program based on acoustics. So in addition to using our traditional gears, there was a call to integrate new technologies like hydroacoustics in a fashion that was sufficiently consistent to allow lake-specific evaluation of fish community dynamics as well as cross-lake comparisons. Now, it's important to point out acoustics wasn't really a new technology at this time. It just hadn't been widely adopted for regular recurring use in the Great Lakes. So why acoustics? And Dan provided a little bit of information on this, but acoustics gives us the ability to see, quote unquote, organisms throughout most of the water column. In fact, it's one of the few tools we have that gives us this type of insight. We can rapidly scan large volumes of water while doing so. There's a wide range of acoustic frequencies that are available for use and application to different types of species, predator fish, prey fish, and we're going to hear a little bit later today about invertebrates like mysis. So acoustics then can provide us this continuous stream of high resolution data when we pair this with trawl information. And so when I say we're able to quote unquote see the entire water column, this is an example of that. We've seen quite a bit this week in terms of echograms like this, but it's a really unique perspective. We're able to see how fish distribute both vertically and horizontally in the water column. We're able to observe patchiness in a much different type of context. There are limitations to what we can see at some of the boundaries, the surface and the bottom, but we've mostly figured out a way to work around this. So I want to distinguish between active fisheries acoustics. We've heard a lot of really great information this week so far, if you've been around for previous sessions, on passive acoustic techniques, which allow us, like acoustic telemetry, to understand fish movements. And to distinguish, active acoustics is where we're transmitting sound pulses and then analyzing the returning echo. So there's really two basic pieces of information that we're interested in, and that's what fisheries grade echo sounders provide us. It's the time delay between the transmission of the sound and the return of the echo, and also the intensity of that echo, which is related to fish size and also position in the beam. This is a similar figure to what Dan showed earlier. So acoustics alone does not really allow us to distinguish species, but we have made great advancements in this, and so we rely on trawling then for species apportionment. All right, so focus here on Lake Michigan and Lake Huron. So there were acoustic surveys conducted in the early 90s and mid 90s in both lakes. But again, it wasn't until the early 2000s that they were widely adopted. And this paper by Gene Adams sort of laid the framework. We can see this early geographic stratification scheme for Lake Michigan that was based on these 3 geographic units. So currently, Lake Michigan is actually split into 6 geographic strata, and Lake Huron into 5. And so these surveys have been conducted annually since 2004, following a very similar design, almost identical. We, in fact, use the same vessels on both lakes, and with some exception. And then in each of these acoustic strata, effort is allocated based on area and variability in biomass. So when we see a lot of variation from year to year, that usually means that we're going to be putting more effort into that particular area. All right, so we have learned a ton of information from ship-based acoustics. A lot of insights into spatial temporal variation in fish biomass. This is some information that Robin showed yesterday, but just based on this entire time series, we can get a better understanding of spatial distribution for species like bloater. Cisco are only caught, adult Cisco are only caught in our acoustic surveys, and in light of a lot of the reintroduction efforts that are ongoing in Lake Huron, it's been really important for us to understand where extant stocks of Cisco are. You can see here over this 20-year period in Georgian Bay, North Channel, and the Manitoulin area. So we got to this point where we have this great information. It's provided new insights, but we knew this issue of vessel noise was a potential bias. And again, Dan did a really nice job sort of setting this up. This is just another study that was done. If you can just picture the motorized vessel approaching, there's a moored transducer, and the fish are sort of diving out of the way. And then coincident with that was this echo intensity on the y-axis, and then ping number. And as the vessel approached, this huge shift in echo intensity reduction. There's other limitations as well, though, with ships. So we have limited time to conduct missions. There's cost considerations, logistical constraints. Between Lake Huron and Lake Michigan, it's over 100,000 square kilometers. These are huge areas to study and to tackle with just ships. And so we also have a lot of uncertainty in some of our estimates. And this is kind of a key point as we look to the future, and including autonomous vehicles to supplement ship-based sampling, is to try to improve some of the precision on some of these estimates. So I don't have to go into too much detail because Dan did a really nice job setting up the whole sail drone picture. But in 2021, there was similar work done in Lake Huron. I can see there was a lot of track laid down by sail drones, 2 different drones. We have the overtakes that were done. And so basically you have the sail drone cruising along a track, and there's the sail drone's acoustic view of the world, and then as the ship approaches, the potential influence of that ship. And so that's what we're measuring. So some similar plots that Dan showed, and again, a really good job explaining them, so I don't really have to at least to too much of a degree. They are a little bit busy, but what did we find? So we have these 3 depth layers: epilimnion, metalimnion, hypolimnion. And here's our response variables that Dan did a nice job explaining. And I don't really want to focus so much on what these are telling us, but if we look at each panel, we can see the ship here and the drone here. And if we focus on the 0 line, we're looking for situations where we see a strong bias in either direction. So we have a few examples. For instance, here, this happens to be with the Spencer Baird. There was a bit of a shift where sail drone was seeing more occasion here with the RV Sturgeon, but generally we didn't see a lot of evidence, and there was rare occurrences of differences at 2 kilometers, and so this is the 2 kilometer distance. So interpretation is we did not find evidence of avoidance in waters shallower than deeper than 5 meters. And here's the target depth that Dan spoke of. Again, if you could picture the fish diving in response to that vessel, we didn't see significant shifts in target depth in most cases. And again, here's 2 kilometers on the to 0, and then here's just the target depth in z-scores. Some evidence here, but generally we just don't see a lot of shift in target depth or position in the water column by acoustic backscatter. So this was done, there's another study that we conducted in 2023, which is going to lay the groundwork for some future work looking at survey designs in Lake Huron. But we can see a lot of work was done, especially in Georgian Bay, by the drone, numerous overtakes. And then we did some work as well with the Stanford Smith. And this was a similar plot to the one that Dan showed as well. A couple cases here where we see a bit of a shift in one direction off of the 0 line. But again, generally, we don't see a lot of effect of the ship approaching sail drone. So this work in 2023 was really in agreement with the 2021 work. So sort of by way of conclusion, and this sort of sets up for the future and what are our next steps and considerations. So we've determined that motorized vessels and ASVs can collect data of similar quality in Lakes Huron and Lake Michigan. I think we've shown that in Lake Superior, in Lake Huron, Lake Michigan. Mark's going to talk next about Lake Erie. We do not see a strong avoidance response from fish due to vessel noise. And thirdly, the ASVs offer the ability to expand the spatial and temporal limits achieved in vessel surveys. So we've really to date just used this particular vessel here, but there are others. So what are our next steps? And this is kind of where we find ourselves today. How do we best allocate resources to increase confidence in abundance estimates? I showed a few examples where we have really high variability for Cisco, for age 0 alewife in some cases. Is this by increasing trawling, by redirecting vessels towards trawling, whereas the drone would do the majority of the acoustics? Do we drive down variance by increasing the volume or the distance of acoustic data collected? And just lastly, that management questions should drive the future of hybrid ASV vessel surveys. So I'll leave it at that, and I'm happy to answer any questions.